Hello, my Algebra 2 students. It's more with rational exponents, which just means more chance to practice here. So let's jump right on in. So with these first ones, they're saying simplify, write the answers with positive exponents only. All right. Something that you have to remember is that when you're dealing with something like this, if I were to do the same question, but I wrote it as x to the 3/5 power times x to the 7/5, I wouldn't do anything to the x's other than keep them and then add the exponents. That's all I would be looking to do here. So I bring that up because if I do it with x's, this would be x to the 3/5 plus 7/5, which would give me 10/5 or x squared. I need to do the same thing when I keep the 25. Don't change it, just add the exponents. So this is 25 to the 3/5 plus 7/5, or 25 to the 10/5, which is the same as 25 squared. I can't multiply the 25s and add the exponents, then I'd be doing the work like twice. So just keep that in mind, that you know those rules, that you're keeping the base, you're adding the exponents. So you might want to add that little note to self to keep the base, add the exponents. All right. When you hit one like the second one, well, that's easy. All right, because there's that same question that I just talked about a second ago. So this would just simply be c to the 10/5, or, oops, not x, c squared, and you're done. All right, if you come on over here, you're just cubing the heck out of everything. So 4 cubed, x cubed, y cubed, so 64 x cubed, y cubed, and you're done. Nothing crazy there. All right, when we slide on down, remind yourself of that rule we just talked about. Keep the base, work with the exponents. So keep the 8 you're dividing. So here we subtract the exponents. And so 1/3 minus 2/3. All right, well, that would give me 8 to the negative 1/3. A negative exponent, I can then take the reciprocal. So it's 1/8, and I can raise it to the positive 1/3. All right. Now it did say leave your answer with positive exponents. So that technically would be it. But this can simplify further. Remember, when you're raising something to the 1/3 power, that's the same as taking the cube root of it. We know the cube root of 8. That's 2. So my final answer here is actually 1/2. I like that one. All right, this next one. If we are taking and raising all of this to the 2/3 power, I'm going to separate this out first. So it'd be 27 to the 2/3 power, and then x to the 3/4 raised to the 2/3 power. Well, power raised to a power, I'm going to multiply those exponents. So this would give me x to the 6/12, which I know is x to the 1/2. Here, this might help to rewrite it as 27 squared, and then the cube root. You can do these in either order. You can square it first or take the cube root first. It'd actually be a lot easier to take the cube root of 27 first, because that's just 3. And then once you square it, that'll turn into 9. So I can leave my answer as 9x to the 1/2 power when I multiply those kind of back together. Or I could write it as 9 square root of x. That would be perfectly fine too. Sometimes it depends on the directions as to which way you leave it, but it's in our notes, so it's good to talk about both. All right, for one like this, same thing. Power raised to a power, we're going to multiply. So this should be x to the 5/2 times 8/3, and then y to the 4/11 times 8/3. It's a little messy, it's all right. Multiplying numerators together, denominators together. This will give me 40/6. This would give me 32/33. Ooh. Well, the y is not going anywhere, but the x we could reduce. We could reduce that down to the 20/3 power, and then this would be the 32nd 33rd power. Ooh. I would just box it in and call it a day. All right, now let's work with some radicals. So if I slide on down here, simplify the radical using exponent properties. All right, so what that means is that I can rewrite these using exponents. So The fourth root of 25 is the same as 25 raised to the 1/4 power. And then think about this one. There's a little 1 right there, so 1/3 power. Right? How you proceed further, we need what are called common bases, or essentially the same base. And what's nice about 5 and 25? Well, they both have a base of 5. So 25 is the same as 5 squared. What we're going to do is a little substitution here. Let's substitute this in place of that 25 there. So take 25 out and put 5 squared in. I'm just going to carry down the rest of this. All right, and now power raised to a power, we multiply. Well, 2 times 1/4, that would just give me 1/2. Now we have the same base. And so the rule, when we have the same base and we're multiplying, we're going to add the exponents. So this is the same as 5 to the 1/2 power plus 1/3. You can get yourself a common denominator. If you're like, I've had it, you can also grab your calculator and go 1/2 plus 1/3, and then math frac that answer, right? That would be perfectly fine as well. And so we'd get 5 to the 5/6 power. You could also leave this as 5 raised to the 5th power in the 6th root. So either way would be fine there. All right, let's flip on over. There's some funky ones on the back that are good to look at together. So here, what I want you to think of is to be able to do this. It'd be nice if we can get it out of the radical first. So I want to start by rewriting it with fractional exponents. So that's going to be step number 1. So the first one is a 4th root. So every exponent will be divided by 4 then. So this would be x to the 4/4, y to the 6/4. The second one, remember, that's just a square root. That means there's a 2 right there. So this would be x to the 6/2, and then all over y. All right, let's see what we can clean up here. So in the numerator, 4/4 is just x. 6/4, I could at least reduce that down to the 3/2. 6/3, that would give me x cubed. All right, now let's try combining. So we have x to the 1st times x to the 3rd. You're adding those exponents to get x to the 4th. And then y to the 3/2 over y to the 1st. Remember, when dividing, we're subtracting those exponents. So 3/2 minus 1 would give me y to the 1/2 power. So this would be my final answer. If it said leave it in simplest radical form, you'd still have the x to the 4th, but then this would just be the square root of y. So I'll put or this. All right, let's do a few more of these together. Let's hop on down to the one beneath it where we have a 5th root going on. All right, so the 5th root, let's see if I can zoom in a little bit. There we go. So the 5th root of y to the 18th means I can rewrite this as y to the 18/5. Down here, y to the 24th raised to the 2/5 power. Remember, power raised to a power, you're going to multiply. So 24 and then times 2/5. This will give me 18/5 up top. If I multiply, 24 times 2 is 48/5 on the bottom. So what looks super messy is actually not too bad because you're going to divide, which means you're going to subtract the exponents. You have a common denominator. That's kind of nice. So this is y to the 18/5 minus 48/5. All right, we'll just subtract the numerator. So 18 minus 48 would give me negative 30/5, which divides nicely. That's going to be y to the negative 6th. And then I never want to leave my answer with a negative exponent. So remind yourself, I can flip this over and now raise it to the positive 6th power. Oof, there's some funky stuff going on in here. All right, maybe we finish with one more here. Let's slide all the way to the bottom. I'm going to change up the directions to say write it in simplest radical form. So rather than using our fractional exponents, let's do one more where what we look at this as is what's my perfect fourth times what's my leftover. All right. In terms of perfect fourths, got to remember 1, 16, oh, what's next? 81 and so on. So 16 divides nicely into 32. So 16 times 2. All right. For it to be a perfect fourth, the exponents need to equal a multiple of 4. And so x to the 20th will work, and I would be left with an x squared. Y to the 8th, that is a multiple of 4, so drop it right in there. All right, 145, holy cannoli. So 145, I divide that by 4. So it goes in there 36 times, so 36 times 4 is 144. All right, so this would be z to the 144 and then z to the first. All right, if I now take the fourth root of 16, if you ever need to double check, don't forget it's under your math key. You can come down to the fourth root and convince yourself that that works. Whoops, sorry, I forgot how zoomed in I was. So fourth root of 16 is 2. And now as for the exponents, you're dividing by 4. So 20 divided by 4 is x to the 5th. 8 divided by 4, y to the 2nd. And we just did this one a second ago. 144 divided by 4 is 36. And then you'd be stuck with this. Now, if we had left it alone and just said, hey, write this with rational exponents, then you would still have a similar type of answer. You would still see the 2 there, but we would end up with x to the 22nd over 4, y squared, and then z to the 145th over 4 times the fourth root of 2. That's awful. No matter which way you look at it, that's awful. But it's a good extension question to look at. All right, that's it. Thanks, guys.